All right, good afternoon, everyone, and welcome to another Iowa Learning Farms webinar. We're excited today to have Jessica Nelson joining us for movement of soil and corn and soybean fields managed with prairie strips. If you have any questions throughout the presentation, feel free to submit those via the chat. Um, you can submit them and we'll get them asked at the end of the presentation. So with that, take it away, Jessica.
Hello, everyone. Looking forward to presenting some of this stuff to you guys. It's going to be a lot of my master's work I did here at Iowa State with Matt Lehman and Rick Cruz and John Tyndall and several others on campus, and using some of Matt Helmer's data with the flumes and the prairie strip sites. So just see if I can get these to advance. There we go. My title slide that I have together with some of our funding agencies that help support this work. I'm not going to spend a ton of time giving the background on the farming landscape in Iowa and the Midwest. I think if you're here, you're probably familiar with it. We farm a lot of corn and beans. We're very efficient at that, and we have great soils for it. So just kind of reiterate, our current land use in the Midwest is predominantly agriculture, with a lot of it in corn and beans. This is also something we commonly see across our landscape, a lot of erosion and water runoff. So we see these incisions creating gullies, sheet and rill erosion, carrying our really fertile topsoil away from our fields and degrading them. And so we struggle with this tension of environmental and agronomic goals. We don't want to take really productive land out of production, but we also don't want to lose a lot of our ecosystem benefits and the value that having a diverse landscape can have on us environmentally, socially, and also it has agronomic benefits through pesticide management and just having diversified systems have a lot of benefits. So I worked on the Prairie Strips project here at Iowa State. We looked at integrating strips of native prairie vegetation along the hill slope in agricultural fields, primarily corn and soybeans, as well as at the edge of those fields, and in riparian buffer zones. And so prairie, if you're not familiar, can have up to 70 grass species and many forb species as well. It's estimated that 85% of Iowa was in prairie prior to European settlement, and now more than 85% of Iowa is in farmland. So we lost a lot of this diversity. We lost a lot of these deep-rooted systems that stabilize the soils, but also produce really rich, fertile soils as well through decomposition and a healthy soil microbiome. So like I said before, we looked at using prairies to stabilize, as well as filter soils along the hill slopes. This is just kind of a diagram of what it looks like. We have rainfall hitting on these prairie strips here upland and stabilizing the soils in those zones. And then we would have a cropped area here where we want to do runoff management, and that runoff would be carried into a prairie strip and assumed to be filtered out before entering a waterway. A lot of my work focused on studying how does soil move on the landscape, and is prairie strips actually influencing it the way we theorized. And so just for a little background, kind of the processes, erosional processes associated with soil movement is first detachment. When you get a raindrop hitting the Earth's surface, that impact causes the soil particles to separate and kind of destabilizes them. And when you get accumulated flows and enough like weight and mass, gravity does what gravity does, and it'll move it, carry it down the hill slope with the water, and without any filtering practices, it'll settle out in low spots and streams. And so we're trying to prevent some of that and find opportunities to intercept it. And so we'll get into kind of the meat of what we did using the mesh pad methods, and then relating that to some of Matt Helmer's and Chris Woody's work with flumes at some of our same sites. So our primary research objectives were to compare crop fields with prairie strips to fields without prairie strips, determine if the rate of infield soil movement is different between the two, and if sediment transport is any different. And while we were studying this, we kind of developed some additional research objectives and questions. And so we're looking at advancing our understanding of soil erosion mechanisms, such as detachment, transport, and deposition, um, using the mesh pad method and looking at the rates of movement, and then kind of determine what other on-site conditions might be driving soil movement. Is there effective rainfall, seasonality, residues, soil types, just kind of trying to tease out some of that stuff. And then the mesh pad methods are relatively not as widely used as some other methods of monitoring infield soil movement. And so we wanted to compare it to more of a time-tested one that measures sediment loads like the H flumes. And so compare these rates of soil movement in the field of sediment loads discharged. This is a little bit of some highlights of our study sites. We looked at rate of infield soil movement with the pads at 12 sites throughout Iowa. And then 6 of those sites, 6 of the 12 had H flumes installed at them. Sites were in a rotation with corn, majority were in a corn soybean, while some were in corn, soybean, and one was continuous corn. We also had a few different this is a generalization of the type of tillage that was out there between the corn and beans. Most of the fields had mulch tillage with 30 to 75% residue cover, 3 no-till and 3 heavy tillage, and then 1 moldboard plow, which was also the continuous corn site. And then the prairie strips range and installation date from 2012 to 2016, and the proportion of fields also varied, and we kind of took that into consideration. So just an introduction to the mesh pad method for those of you that haven't heard this before. The mesh pad method was first introduced in 1992 by Dr. Shea, and was found to assess greater amounts of total soil erosion than the runoff plot methods they tested. It uses small pads, anywhere from 100 to 900 centimeters squared of fabric is what Dr. Shea was working with. There's 2 layers of fabric. There's a nylon mesh that has a pore size of approximately 4 millimeters stapled on top of a no-seam netting with a pore size about 0.1 millimeters. Water is allowed to move through the pads, while the pore size prevents soil particles greater than 0.1 to infiltrate or to leave the pad. And then we'll get into more our specific experimental design and how we use these pads. So we used a paired field comparison or a paired comparison approach. In this image here, there's a control field, which is the one on the left in like the orange yellow color. And then there's our field with the prairie strips, which is the green chunk there in the middle and at the edge of this field. And that's denoted the field boundaries in the blue outline. And then each of those circles are our pad locations. So there's 12 of these pairs with a control and a prairie strip treatment. There's 3 different landscape positions per field. And so above here, which is hard to see the strains from south to north, on the south side is the top of the field. And we put 10 pads there, and then we put 10 pads in the middle, and we put 10 pads at the edge of the field, kind of in the bottom slope position. And each of these pads were 15 by 15 centimeters. And just here's a picture of what they kind of look like. They're real tiny. They're kind of fun to work with. There's a clean pad on the left side, and then a dirty pad that was brought back to the lab on the right side here. Just kind of what it looks like after being weathered in the field with some soil captured. We replaced these pads after at least 50 millimeters of rain. We used the Iowa Mesonet, and we did this approximately 3 times per year. These measurements were taken only during the growing season because we didn't want to interfere with typical farm management practices. So we'd wait till the farmer would plant their crop, and then we'd communicate with them for a good time to come out and deploy these mesh pads. And then throughout the growing season until about August, we would collect soil samples. And just here is some more pictures of what it looks like out in the field. On the left side and the lower right of that picture, there's a pad buried in the soil. So they're real small, but they're capturing quite a bit of information. There's above the strip, between and below. And we extrapolated out weight per area per day. So we looked at how much grams of soil were captured on this pad, this 15 by 15 centimeter pad, and how many days was it out in the field, and then turn that into kilograms per hectare per day. And so another question while we were studying this was like, what type of erosion process are we capturing with the pad? How much can be attributed to that initial erosion process of splash and kind of the soil detachment, and how much can be attributed to more the transport phase where it's accumulated flow and how much soil is being deposited on there. So in 2020, we took a subset of our 12 sites and looked at 4 sites and did a pair pad study. And this included a pad with this red, we called it a V diversion to prevent any surface flow paths upslope from draining down and intercepting the pad. And then about 2 to 3 meters away, we had an unprotected pad with no V diversion that had both splash erosion and overland flow contributing to it. And we had 18 of these within a field. And just, they were solid 40 centimeters upslope. We did some research to look at how far soil particle typically moves due to splash erosion. And here's an upslope look of what that middle V diversion looks like. And we followed our other mesh pad methods for collection. And then, like I said before, 6 of these sites had H flumes, so we could monitor sediment transport to do a paired comparison approach, looking at prairie strips versus no prairie strips, the control. So again, the orange on the left side of this image is the control, and the blue outline is our prairie strip watershed. And then we can compare these to what's happening at the edge of field to within the field. So we had 1 flume per watershed outlet. And here's what a picture of a flume looks like. So within that watershed, all that land mass is contributing to this one spot, and there's runoff, rainfall, nutrients, and sediment being monitored here, and flow rates. And so I'm just going to talk about the measured total suspended sediment loads and summarize those by sampling event. So anytime this equipment was triggered to sample water and there was a TSS load present, that's how we'll be talking about this data. Just kind of what low turbidity versus high turbidity looks like. Rainfall accumulation rate and intensity were calculated from the rain gauge there. And this was measured outside of the pad time. So it went from measurements of the H flume started from thaw in the spring till freeze in the fall. So we could capture the whole entire year. Just kind of on the landscape, this is what that looks like. What would be contributing to the H flume. And a load is being classified as kilograms per hectare. And this is kind of our reach throughout Iowa. We covered a lot of different of the landscape. Wherever there's a purple dot, there was a flume plus a mesh pad experiment occurring. The blue dots is where only mesh pad work was completed. And then the yellow dot was one flume site that had no mesh pad experiment. And then these are our sites in 2020 to look at V diversions. For some of the nitty gritty of the statistical analysis, I won't go too deep into these details, but a little bit of explanation. Our treatments were randomly located at 4 sites. So those are the sites where we can make causal statements, whereas the full data set includes private commercial farms. And so a lot of the prairie strip treatments were placed in places where the farmers had resource concerns, and we were being sensitive to that. And so I'm going to only talk about the full data set, so that we can't say a cause and effect, but we can talk about what we observed and measured and kind of make those comparisons. And then we created a mixed linear model with ANOVA test and contrast in RStudio. Factors representing components of the experimental design were included in that model, such as the year measurements were taken, the research site itself, and then the treatment, prairie versus control, which crop was planted, corn or soybeans, took the log of rainfall accumulation, and then the sampling period. And for pads, that was the time, was it 1, 2, or 3, or a sampling event for flumes. So getting into the results, the treatment effect prairie versus control. Our primary objective findings was that, is there a difference in rate of infield soil movement between paired treatments? No, we did not measure that across our full data set. It was pretty much the same between the two. However, sediment transport at the edge of field, there was a prairie strip. We saw a difference between prairie strip fields and control fields. In a lot of cases, there was one case where we didn't see a difference, and I'll get into more explanation of why that might be and what we observed. But here's kind of the median mesh pad data is reported as median, since there was such a large array of, or large range of values. And then flumes reported a mean. So again, just kind of pictorially or an illustration of what was collected, rate of soil movement, treatment by year. There's no significant differences between prairie strip and control. I just want to, I don't know if you guys can see my pointer options, laser pointer. Right in here is where we're measuring. So within the field, it's, we didn't see any difference in these zones between the crop zones of the prairie strip versus the control. 2019, there might have been something, but it wasn't significant enough. And this graph is median rate of soil movement, and then these bars are the confidence intervals. And then in this figure here, we're looking at the primary growing season of when mesh pads were deployed and the full data set. And any gray bar that crosses this dotted line is considered insignificant. There's no difference between prairie strip response and the control response. And so these would be considered statistically insignificant. So there's no difference between the two treatments. And when we look at the H flume data, we also see that same thing. When we look at treatment and the interaction of treatment with crop and year. So one might say, okay, there's no difference, but that's not the whole picture. And fortunately, we have the H flume data to be able to show what the yearly annual differences are outside of the primary growing season. So there's a lot of factors we found that are influencing this movement of soil. So yeah, we dug deeper. What are we measuring, and does the wind matter? We looked at the H flume data outside of that primary growing season, so kind of March till April, middle of May, depending on when crop planting was that year, and then the fall season when crops are more dormant. We saw a treatment effect where prairie strip had less soil movement than the control did. And we saw an interaction of prairie strips with corn, and when corn was planted that year, we saw significantly less soil or sediment transported from a prairie strip field compared to a control. And we also saw some years there was less movement in prairie strip fields than there was in control. And we looked at the whole year, we still saw that there was less movement and less sediment transported from a prairie strip field. And we still see this interaction with the prairie strips and the corn, and these differences in 2017 and 2016. And so we asked ourselves, how can we see these differences at these different times a year and annually, kind of what's going on? And so that's kind of also what motivated some of the 2020 study. This gets back to that paired pad study. We'll do a little segue here, sorry. There's no significant differences between pads that had that V diversion that was put upslope. And so from that information, it tells us that soil detachment is due primarily to splash erosion. So those pads are just measuring what's going on upland in the field and not necessarily what might be running off from the prairie strip. And so that's kind of an important piece of information so that we can see what's going on upland, and how different farming practices are affecting the stability of soils. And so when we're comparing what's going on in field with the soil pads to the edge of field with the H flumes, we see that the TSS loads discharged from a field is significantly positively associated with rate of infield soil movement upland. So fields with more sediment running off tend to have more infield soil movement. So it's kind of validating that the pads are observing something upland that the flumes are, but in maybe finer detail, to get at some of the farming practices. And we also saw that soil movement and transport is significantly influenced by rainfall. And so rainfall was an important part of this picture that's kind of influencing what we're observing. So one theory, we found that interaction with crop was so significant in the age flume study. And so maybe the crop planted and the residue present in the spring is a huge contributor to what we're seeing. And so when we have fields, when corn is planted, there was less movement in a field with prairie. And one of the theories is because there's a soybean residue present. And so soybean residue doesn't necessarily provide as much ground cover and production or protection as maybe a corn residue might. And so there's could be more soil disturbance and runoff, soil runoff due to that than water impacting this corn residue. And so rates of infield soil movement were significantly lower in years following corn, particularly at the middle and bottom field positions. Using the pad data, the interaction of crop with prairie strips was a significant factor affecting sediment transport for the TSS loads in years following soybean. So getting back at the rainfall, kind of part of the story, we looked at the primary growing season. These were the type of rainfall rate intensity classes that we had observed, which is substantially less than what was observed and measured outside of the primary growing season. And so with the pad data and the flume data, and we're just looking at the growing season, we might be missing some of these higher intensity, heavy and violent rain events that are causing some of the erosion. And so that could be something that's contributing to no difference with prairie strips in the growing season, and also the crop starting to canopy and provide some protection to the soil surface. And then this figure here, one of the results we saw was that there wasn't necessarily an interaction with crop planted with the prairie strip treatment, but there was a significant difference. There was more measured or higher rates of infield soil movement in fields with corn compared to the fields when they're planted in soybean. And then this is a depiction of that relationship or the response ratio we saw before. Sediment transport from the H flumes, treatment by crop interaction. When corn was planted, the TSS loads were 96.8% lower in prairie strip subcatchments compared to the control. And in soybean years, when the residue was corn, TSS loads did not vary significantly between paired treatments. And so kind of to conclude some of this, prairie strips seem to be influencing the type of sediment transport we would expect at times of the year when the fields are more vulnerable. There's not, as we grow primarily a summer crop here in the Midwest, there's not as much crop canopy cover, and the residue might be playing a role in that. There are instances where prairie strip treatments performed similarly to controls, which may be due to year variations in environmental conditions and rainfall patterns. And this is something kind of outside of our study. Another paper I was reading, it's predicted that there's going to be a 30 to 70% increase in warm season rainfall in the spring throughout the Midwest with climate change. So there'll also be an increased frequency and intensity during a period when there's typically no crop grown. And so some of this work to study soil movement and the relationship of different conservation practices and soil protection is important. We kind of need to advance our understanding of some of the erosional processes at play in our corn and soybean systems, and using things like this mesh soil pad can help us understand where and how to trap and prevent and stabilize our soils before they leave the field. So kind of where does this take us? There are annual differences that need further explanation. There's also some site-specific design of the prairie strips that may be influencing results. So spacing, strip width, age of vegetation, and maybe changes in farm management. Kind of in my mind, having some sort of filter strip out there within the field or at the edge of field is an important thing to do to get compounded erosion benefits. And there's something similar. There's contour buffer strips, which is a monoculture of cool season grasses, measured to get 37% reduction in water runoff. Or you could go with the multi-purpose prairie strips. That is a diverse native prairie mix, and you get similar water runoff and reductions in sediment and nutrient benefits, but also disproportionate benefits for wildlife habitat and diversifying our landscape. So it's kind of, would you like to see something like this with flowers and different grasses intermingled with corn and soybeans and more birds and wildlife? So yeah, and I'd be remiss to acknowledge and thank everybody that's helped make this project happen and shape it. So thank you guys. For that, I'll take some questions. This is just a little figure of what soil pad collection looks like. Omar made this this little cartoon here. So if you're curious on the process, there it is.
All right, so I'll let Jessica take a drink of water. Please submit your questions to the chat. But we have, if you joined this webinar would like a CCA CEU credit, please email me, Alena Whitaker, ALENAW, at iastate.edu by 5 p.m. today. Include your name, the name you entered to watch the webinar if it's different, and your CCA number. So again, email Alena W, ALENAW, at iastate.edu by 5 p.m. today. You could hit the next slide, please. Yes, and then so if you have tuned in at any point this year to watch any of our webinars, if you could fill out our demographic survey. It is a voluntary demographic survey, and if you've done it already once for 2023, that's fantastic. We only need it one time for 2023. You can find it at www.iowalearningfarms.org/survey. And then join us next week for Dr. Catherine Densman. She'll be talking about community approaches to pesticide resistance and management. And then just a special kind of announcement, if you want to go to the next slide, please. We are going to be having a new link for all of our future webinars. They will be using the Zoom webinar meeting function. We will be advertising this a lot this next week. And so please join in if you want to take a screenshot of that, or I'll include the link here in the chat for the new webinar if you want to record that, just so you know that that is coming up next week for our webinar. And all right, here it is in the, oh, maybe, actually that did not, okay, I think it did copy over correctly. So join us next week at that new link. All right, so with that, we do have some questions. First question is, this person missed the beginning of the presentation. They're wondering, was a corn on corn system tested as well as a corn soybean, or was it only a corn soybean corn oscillation?
Continuous corn was one of our tested sites. So we had all three of them. Yeah, all three of them.
Perfect. All right, and then so was there a variety of different seeding not necessarily seeding methods, but like seeding plant mixes? Was there a variety used throughout the different prairie strips?
There was a variety used. It kind of depended on where the funding source was and what the farmers' goals were, but there were diverse prairie seed mixes used and recommended establishment methods. There were varying prairie species diversity at all the sites. Say all of them were greater than half prairie species, some up to 80 to 90%, but there's one site that was 30% established. I think it just was struggling and needs some additional management and reseeding out there. There's still grass or vegetative filter strip. It's just some of the weedy species were taken over.
Perfect. And then we have another question. Did you find differences in prairie strip versus controlled soil movement between tillage systems?
We didn't test tillage systems. There wasn't enough data. We kind of didn't realize the effect of crop planted towards the end. And so we weren't measuring from 2016 to 2020 all the specific tillage management practices. I think that's something I would encourage people to do moving forward. There's a group out of the University of Minnesota that's using the mesh pads in Minnesota and Wisconsin to look at like what different tillage systems and cover crops do to infield soil management. That's something that should be pursued.
Perfect. Another question, were all the sites using tillage in the cropland, or were some of them actually using no-till?
Some of them are using no-till. There was 2 sites, I believe 2 or 3 sites that were no-till.
Another question is, did all the sites have the same width of prairie strips?
No, they didn't have all the same width. Some were really wide. It just kind of depended on the slope and the design of the design specific to the field. They were different. How long had the prairie strips been established? Are longer established prairie strips more effective at trapping moving soil particles? We didn't look into the age when we kind of plugged that into our model. It didn't pop up as a significant thing. It would be something to look into to compare kind of the proportion of stiff stem grasses to maybe a cool season, weaker stem grasses, and see how effective they are at trapping soil particles, like grass waterways. They're designed to have grasses that are okay being kind of mowed over and filter out so that water can drain through there. Whereas when you want a contour buffer strip, you want that to be a filter strip and have a stiffer stemmed. So something to look into might be the stem density and kind of how good it is at filtering those out. But we didn't look into it for this study. And then another question is, how do you install the pad on the soil surface? Oh, I saw that one. And then were there differences in characteristics of the prairie strips, what was planted or how old established the prairie strip was? I think I kind of answered that. There'll be a paper coming out that explains more of the diversity out there, but again, we didn't see an effect of prairie strip age. And so we didn't do, for my study, we didn't do any vegetative surveys, but Lydia English with Matt Lehman, they have a publication or a thesis that has that information reported out on each site, what prairie species were present and what was their plant or their diversity and the effective age on that as well. Question is, why would you expect differences between prairie strips and non-prairie strip fields? I'm not, so for soil movement, we would expect differences in a prairie strip field. I might just go to a diagram here, kind of towards the end. Because the way, I guess this might be a good one. So without having something to intercept these flow paths, they continue to just go along the hill slope and build momentum and build erosive force that kind of degrades the hill slope. And having things like prairie strips or a filter strip breaks those flow paths. And so you're dissipating some of that erosive energy and providing a space to filter out the soils. And so in a perfect system, if they're installed in the right location along the hill slope and designed well, they'll reduce the runoff and the erosive energy and provide a space to filter out the soils. And if you don't have anything intercepting that runoff, we see fields like what I showed in the early slides that are just kind of scarred up with gullies and a lot of erosion. Let's see. Yeah, so this is a field that doesn't have anything intercepting these flow paths, and so it might benefit from a grass waterway as well as some sort of filter strip intercepting those flow paths. And the question was, isn't that what terracing is for? And yes, terracing is one solution. Typically, those are more used on a higher slope percentage. when I do a lot of my watershed modeling work, we'll site terraces on fields with greater than 10% or 15% slope, whereas contour buffer strips are more suitable for kind of like a 5 to 10% slope. And then you also get a lot more wildlife benefits as well when you use something like a prairie strip with a diverse seed mix. There's some work being done at Iowa State to compare places like terraces and contour buffer strips with those cooler season grasses to see some of the other ecosystem services benefits out of it too. Good questions. Thank you.
All right. And yeah, that's all the questions I'd gotten. So thanks again, Jessica.